Hello, my name is Ginnela Someswara Sai Prasad. Today, in this session, probability concepts like definition, axioms, joint and conditional probability, total probability, Boy's theorem. Let's go. Introduction. Probability. What is probability? First of all, in this probability, we have discussion that if we have some possible outcomes, like we know with total probability, if we use that probability we can predict what is outcome. Like if you, for example, tossing a coin whether forecast today is rain or not, exam results, if we have some inputs data we can calculate that total probability. Applications where we use probability: AI, risk management, finance, engineering. In day-to-day life, we use some probabilities. Like we just think if we go outside, the today's sky, yeah, if it's a cloud, we can predict. If the rain is coming, we bring umbrella. If not, we don't take umbrella. The probability, we in our minds we use the probability without knowing that we are using. But in our day-to-day life, we use probability by thinking, or just we can manage or something else. For example, let's go. Definition of probability. We already say that, but again I will tell in clear. Definition of probability. P of A means probability of A. Here A is a certain event. Favorable outcomes by total outcomes means we have no some probability of something event that is favorable to us. Means if you have die a, if you have toss or a die event A for a suppose event of numbers, like even numbers. Even numbers in a die have 3. Total number 6. Here favorable outcomes are 3. Total outcomes are 6. So the probability is 0.5. Axioms of probability. In this session, what is that some axioms we tell about that. So first thing is non-negativity, means the probability never gone to negativity. It's either 0 or greater than 0. Second one is P of certain event is 1, and if it is mutually exclusive, means the probabilities are both have P of A plus P of B, means the both have no common output. Like if we see a die a roll P of 2 or 5, in this we have 1 by 6 plus 1 by 6, total 1 by 3. That's it. Axioms are completed. So in the space and events, means space is nothing space. In sample space is a possible of outcomes, means if we have a event like that, a subset of event of yes we I explain in later, but this is most we use in, it's a fundamentals. Sample space is a all possible outcomes already said. Event, a subset of S, means event event of A, means it is a subset of S means here sample space. For example, if a coin a toss, here sample space are head or tails. Event head means H is a subset of toss. Understand? That's it. Types of event. We have mutual exclusive, which can't occur together. Means they are independent. There are not dependent or not common outcome. So A intersection B is P of A intersection B. Yeah, is equal to 0. For example, head and toss in a one toss. You don't get head and toss. Like if we toss a coin, we get a head or tail. That's it. It's a certain events. So it's a mutual exclusive. Independent. One does not occur the other. Means if it occurs, that not occurs in other. For example, tossing two coins. So P of interaction B, P of A into P of B. So if you toss that two coins, there are independent events. So that's it. Events are completed. Joint probability. Joint probability. This is a probability of together. The event occur with in both means it a joint. The two outcomes are and maybe it's like a probability of occurring together. A event occurring together. That's it. If for example, hmm, even A is a even in a roll of die and B is greater than 3. That is A intersection B is 4 comma 6. Here we get P of A intersection B is 1 by 3. Means that are there in both we both conditions satisfy, therefore the outcomes is 2. So 2 by total we have in the 6 total outcomes, so 2 by 6 is 1 by 3. Examples of joint probability. Given P of A, here I saying this, here 0.4, P of B 0.5, P of A intersection is 0.2, then P of intersection is 0.2. Again, if independent, yeah, P of A into P of B is equal to 0.2. That's it. If independent, there are both probabilities are multiplied. That's it. If you go conditional probability, it's idea. Yeah, conditional probability. We discussing. It's a condition. Means P of A when given B means already we know probability of something and we want probability of what we want with given B or in this example we see. For example, a formula is given P of A when B is given P of A intersection B by P of B, where P of B is not equal to 0. Because if P of B is equal to 0, then it's maybe become infinity. So probability never going infinity. That's it. P of P of red when hearts. Means if we do a deck of cards 52, that is probability are 1. Means the hearts are 13 and the red is 1. So that's it. A simple ideal example. Examples of conditional probability. One more you see in this slide, and this is a P of even greater than P of even and greater than 3 we want. So let us assume P of A is equal to even P of B greater than 3. So intersection B sample space have two outcomes. So the Z 2 by 6 is equal to 1 by 3. P of B is equal to, again we calculating P of B. So 3 by 6 is equal to 1 by 2. That's it. P of A and B is given. Means we want even number greater than 3. So we use that formula 2 by 3 answer. Law of total probability. For example, if we have total probability, means we have some partitions like sample space. I already told that sample space is that voice is clear. Okay, that's P of B1, B2, Bn. That's sample. For example, it's a set of P of something is that P of B1, B2 partitions are in sample space. Then P of A is equal to P of A. Before that, I example explain that formula. P of A summation P of A, then Bi means Bi is partitions of B1, B2, B3 in a sample space. Yes, into P of BI. It is used in disease caused by multiple source, air contribution for each source. Yeah, total probability is some partitions is given, that is we are multiply that all and take that total probability. This is helpful in for example, build a factory. A machine is 60% output and defect is 1%. Machine 2 is 40% output, defect is 2%. P of D, we calculating that. So you see that calculation, the output is 1.4. Yeah, you put this time Boy's theorem. Boy's theorem used reserve conditional probability formula. P of Bi and A given P of A Bi into P of Bi by summation P of A Pj into Pj. That's it. Here some textbooks have different formulas. Yeah, that's it. We use different formulas, but basic concept is it is reverse of conditional probability. That's it. Examples of Boy's theorem. For example, if you take that this is a person that we can find with positive test each time we update it, means Boy's theorem. If we have a new output or a new result, we use that in that Boy's theorem, we can update it, means it's a most complicated, not we use so many times, but Boy's theorem have some more applications like insurance, finance, risk analysis, and gaming, and AML like prediction in engineering, reliability analysis. That's it. Application of conditional probability. Yeah, weather forecasting. Rain is given clouds. Yeah, if we rain are given clouds, means we have see when we go outside the clouds are there. That's it. We can predict, oh, these clouds are there, we get some probability. That's it. Sports prediction, which team win or that manufacture defect rate. So that's it. Application of Boy's theorem. Space filtering, that's not space filtering, spam filtering. Yes. Medical diagnostic, this fraud detection, machine learning modules, where we use something Boy's theorem. For example, I already say Boy's theorem, that's a using we are that we have some input, we updating each time. That's it. We simply close that common misconceptions. So many people that's mutual exclusive not equal to independent. That's it. Thinking that mutual exclusive means not occur. That's it. That not equal, not independent. That both are different. Probability always not fair. Conditional not equal to joint probability. That's it. Key points to remember. That's it. We come to final session. So in this last slide, we end this session. So if you P of the probability lies between 0 to 1, that's it. Joint is equal to P of A intersection B, or again P of conditional, that's it, probability of conditional P of A when B given, total probability. Breakdown of complex events. Yeah, we breaking complex event into something parts. That's it. That again come to get total probability again. Boy's theorem. Yeah, reverse conditional probability. That's it. Thank you for watching. Bye bye guys. Your scientist Ginnela Someswara Sai Prasad. If you notice any mistakes or any other things, you just comment down in comment section. Thank you for watching. If you have any doubts, please comment and I will explain my level best. That's it. Thank you guys. Bye bye.